So how would I detect a button being pressed once, twice, many times, or pressed for a long time on an F4? Well, it's not difficult. You can use timers, and let me show you how it's done. So I'm going to create a project here, call it button pusher. And we're going to use as much of the default parameters as we can just to focus on only the code. We're going to start by simply having a button that we can detect when we press it and when we release it. And then we'll add the additional functionality. So here's the initial settings, it's empty. So we are going to just set the connection type for programming, right? So there's no confusion. I have those buttons already assigned. This pin is for the onboard LED right here, and the button I'm going to be using is just a push button connected to A0 and ground, and with a debouncer capacitor. So it's a 0.1 microfarad capacitor just for debouncing the signal. So we'll change this one for output, give it a name, LED, and then our button is in A0, this one here. It will be an external interrupt. We'll give it a name, button, and we need to make some changes to those pins. First to the LED, because it's connected backwards, we're going to set it to high in order for the LED to be off. And for the interrupt, we are detecting rising and falling edges, and we want to have a pull-up because we're pulling it to ground to detect it, so we want to have voltage in there. We don't want it floating because we're not connecting anything else, no external power. And also we want the interrupt enabled. So that should be it. Let's generate the code. All right, so this is our file. First thing we're gonna do is go get the interrupt. Callback. All right, so this is the one we want. So this function will be called every time the voltage rises on A0 or if it falls. We're gonna put it here. And first thing we would want to do is detect if GPIO pin is equals to our button pin. Right, and if it is, now we want to detect if the button is being pressed or not. Because it's being pulled high, that means that when it has voltage, it's actually being released, and vice versa. So let's go look at the button port, IDR, and button pin. So this is button released. Else, so this means the button is pressed. So when this release, GPIO write LED port, LED pin, GPIO pin set. So because it's connected backwards, when we set it to high, it will be off. So this will turn it off. And to turn it on, we just reset it. Okay. So let's compile, make sure there's no errors or warnings. Here we go. Let's send it in. And let me enable the camera. So when I press it, the LED will turn on and turn off when I release it. So there it is. So if I press it, it goes on, release it, goes off, on, off, right? So now let's detect how many times it's being pressed, how long it's being pressed, and when it's being released. So to do that, we are going to use a timer because we need to keep track of time to see how long they're pressing it and how many times. We're going to use timer 11, and we only need a single channel, so this is perfect. We're going to select output compare no output because we don't need the output. We need the interrupt enable, and on the settings, because we are running a 16 megahertz, I want to divide each count, or make sure that each count is only done at 1 millisecond. So I'm going to set the prescaler to 16,000 minus 1, which will mean that each count of this is 1 millisecond, and I'm gonna set it to expire at 500. That should be it. So we have our interrupt, we have our settings, we can generate the code. And the first thing you want to do every time you use timers is you want to enable those timers, otherwise you will end up forgetting. So we're going to enable the base interrupt timer and also the channel for output compare interrupt. Okay, so that's it. Now we're going to go and look for the two interrupt routines that we're going to use, and those should be under this header file, and they should be under output compare right here. So we're going to use this one here, and this one triggers when the idle reload overflows. All right, so we're going to use this to set the final result of the clicking or the button presses. And the other one is this here. This will be used to detect if it's a long press when we set the time and it expires. So we're going to need a few things here. So first, we need a way to file 16 bits. We need to have a global variable to detect how many clicks. We'll set it to 0. We also want another one to keep track of how many times it's being clicked before we set the final result. Right. We also want to keep track of the type of clicks we can use. We don't want just a number, we want something that is readable. So this will be a click type, and it should be a press type, not a click type, but we'll leave it a click. So we have no click, and single click, double click, and multi-click, long click. That should do it. We'll have one that just click for simplicity, and another one for click state. So we know what is happening with the button at any given time, and then click will, or this one here, click will store the final result once we're done clicking. The other one, just for simplicity, okay, and this will be utilized to see if the button is being pressed, or if it's down, I should say, and if the clicks are validated. So if a click has been resolved, then we want to know if it has. So let's start with this function. This is the one that validates. Actually, let's start with this one. This will be easier because this one is just for long click. So first thing is, whenever you're in an interrupt, you want to make sure that you execute your code only when what you're looking for happens, right? So in this instance, we want to make sure that the instance or whatever is calling this function is the timer we're looking for, right? So it has to be timer 11. And also, we want to make sure that the channel that is being called as well is our channel, which is channel 1. If you don't know which channel that is, it would be this one here, right? So this one here, channel 1. So let's see, active channel, channel 1. And if it is, then we can say click state equals long click, right? So now we can detect our click. We also want to make sure that the button is down as well. So only when you keep it down is when you want to have a valid long click. So you have to keep it down for a while. The other one here is, since this is going to resolve the final click, we want to make sure that the code is only executed once. So if it's resolved already, then we just return. Otherwise, it's true. In clicks, click count, we'll reset it to 0, and then we'll save our final click. So this will be click state, and I guess we can say click state as well, reset it to no click, right? Because it's done. We're done pretty much with it. And that should do it. All right. Now, the difficult one here. On this one, so if you have a button down and the time expires where you validate your click, when you release it, it doesn't matter anymore. So if click resolved, then we don't want to do anything with it. Okay. Now we want to check our timing parameters to see if this release, when we're releasing this button, does it qualify for multi-click or a single click or a long click or whatever it is, right? So if the count is less than 250, so 250 milliseconds, we'll say if it is within 250 milliseconds, then it qualifies for an accumulation of clicks, so we can detect multiple clicks. So click count is equals to 2. Well, I guess if we're going to do that here, then we have to say button click count. We're going to increment it. If it's 2, then click state should be double click. Okay. And if it's more than 2, then it's a multi-click. Or if it's none of those two, then it must be a single click, right? So when the code lands here, if it hasn't been resolved, it will check to see if it's within 250 milliseconds, and you'll see why in a minute. If it is, then it'll increment the count, and then as it increments the count, it'll check to see if it's 2, then it'll set the state to this, this, or that. So the first time it comes around, it'll do this. If you click it again within 250, it'll do this one here. And if you click it again anytime after, then it'll keep doing this one, which means that we need an else here. And we can say button click count equals 0. So we want to change the idle reload here and set it to less than that, right? So that if it expires when you release it, then it has 210 milliseconds after you release the button to go here. and say this is the final result. All right, so the count set to 0, so you can restart. So that would be it for that one. Now on this one, we want to keep track of the time as well. And if it's more than 200, so if I release the button, I press it again, and it's more than 200, then this cannot count as a multi-click. So this will be set to 0. And we want to set click resolve to false because we're starting a brand new press, right? So this hasn't been resolved. We're starting something fresh. So now we can set the timer and set the idle reload to, let's say, 505, right? So a little bit over half a second. And then we're also going to set the channel 1. So the capture, the counter, I don't know, output compare, whatever it is, on channel 1, we're going to set it to 500. So when I press the button, if I hold it for, if I don't release it, this is going to expire first. So this is going to trigger this, and it's going to set it as a long click, which means that I have to set this flag if I haven't done already. I have not. Okay. Oof, come on. And if I release it and I don't press it again, then this is going to expire next. Or I should say this might expire next, right? So if I hold it for 500, this is going to run. And if I keep holding it in the next 5 milliseconds, this is going to run. So it's going to detect this click, long click, and then immediately it's going to jump onto this to finalize the click. And finally, we set the count to 0 to restart. Let me compile. No warnings, no errors. So let's see if it works. All right. So I have here my live expression. So we're going to look at, let me run it first. And then, so let's set whatever is final at the top. So final is the click. And also the button clicks. And then below that, let's just set something run. Just something to create a gap in between so there's no confusion of what we're looking at. So now we're going to set the button click count, or actually the click state, and the click count, and the button down, and resolve as well. So there we have all of those. So let me show my device here. So if I press the button, we'll see an LED light up, but also here we're going to see everything change. See that? Single click, long click, multi-click. Obviously something's going wrong, so I have to figure out what that is. But you can see that it's a single click, double click, long click. So let's see what I did incorrectly here. Let's figure this out. Wait, hold on, let me see. Let me press it again. Yeah. So something's happening with this one. I believe I'm not setting it. Yep, I'm not. Alright, so when I press the button, it's already being set to true. But when I release it, it's not being set to anything. So I'm going to set it right at the beginning here and set it to false. Let's run it once more. So let me press the button. There it is. That's a long click, it resolved, right? Let it go. Press it once, single click, it went all the way to the top, it was resolved. How many clicks? No click, it was reset as well. The button's not down and it's been resolved, right? So if I hold it down, you can see there's a timeout and then a long click, and I release it and nothing happens. So if I press it twice, there's a double click right here, right? Once, twice, 3 times. That's a multi-click, or I can hold down. So that's it. Pretty simple.